Hi, so a friend of mine has some questions about binary number system, and I thought why not make a YouTube video? This way, her and maybe somebody else on the internet can find it helpful. So first of all, binary number. As we all know, we use something called the decimal system, decimal, and what that contains is zero, one, to all the way up to 9, right? So this is all the numbers that we could use. Now computers, as we kind of might heard of before, but computers are binary. They understand only binary, which means computer either understands 0 or 1. And if you kind of think about it, computer uses electricity, right? And inside your computer, you have different parts, right? Your CPU, your motherboard, RAM, hard drive, and all that. And so now, let's say you have your image, right? Like you have a picture and you store it onto your computer hard drive. What it really means is the picture is turned into zeros and ones, and it's stored inside your hard drive. And when when you wanna put up that picture, you open up a picture program, click on the picture, and it opens that picture for you. So it converts from zeros and ones back to your original image that you can see on your screen, made up of pixels. So, all right, so let's just get to the point, how this really works. So let's say I have a number. Let's say I want to count the numbers. So decimal on the left side, decimal, and then binary. Okay. Oops. Okay, so we have 1, 2, 3. Oh man, I should have made this ahead of time, but you get a point. 6, 7. Here. Well, I'm actually illustrating a point here, so maybe you might find this helpful. Okay. So decimal 1, right? What 1 really means is it's just a 1 number. So let's say I have an arbitrary, let's say 148, right? Okay, let's do 147. It's an odd number. I like odd number. Okay, so we have this number. And what it really means is it's 100 plus 40 plus 7, right? So in the ones place, I have a 7. In the tens place, I have a 40, and the hundreds place, I have 100, right? So like think of it like money. Think of it like money. Then we have let's do 125. So if you want to pay somebody $125, you have a $100 bill plus a $20 bill and a $5 bill, right? That's how you create this $125. And so just know that this corresponds to this digit, this corresponds to this digit, and that. And so 1 in binary, right? Just like our system, computer understands 1. Oh, so before this, I have to insert below. Okay, so 0, 0, right? So decimal starts at 0, binary starts at 0. 0, 1, 2, good. Now, since binary only goes up to 1, just like how, let's say we have 9, right? 9 cannot get any bigger, right? So 9, what happened is 9 becomes 0, and we add a digit before the 0. See what happened? 9 became a 0 in the ones place, and then we introduce a new tens place. Okay? So same concept here. If binary can only go up to 1, that's the maximum, then it becomes 0, right? The digit becomes 0, and we have to introduce a 1 in front of it because it's pushing 1 digit forward. All right. 3, 1 0 plus 1 is, right? Because I can make this 1. Now this 1 is full again, so I have to make this so the 1 becomes 0, and then that means I push the 1 forward. But at the same time, so I have this. So watch carefully. 11 plus 1, right? So what happened here is, here I have, oh my goodness, this is gonna be a pain. Okay, so this becomes 0, right? That means I have to push a 1 forward. So the 1, so I introduce a 1 here. Now 1 plus 1 again is another conversion, because 1 plus 1 is 2. There is no 2. So this becomes 0, and we have to introduce another 1 in the front. And so we end up with the number 100. And now, because this is 0, we can just make it 1, right? 1 bigger. And if you notice, now we have to add, this, right? 1 plus 1 is 0, right? It's 2, but 2 becomes 0, and we just push a digit forward. Just like how 9 becomes 10, we push a digit forward. So 1 plus 1 is 0, and then we introduce a 1 here, right? We push a 1 forward, and 1 plus 0 is just 1. So we keep it, and then there's another 1, so we drag it down, and so 110. And if we notice this pattern, then we know, since it's a 0 at the end, we know we could just increase it 1. We add 1 to it. That's it. And now notice here what happened here, because if I add a 1, it's gonna make everything 0 and add a new 1 in the front. So if you think of it like the same things, same situation, so it's gonna be 1, and then the 3 ones become 0, and blah blah blah. It just keep going on and on. And so 1001, right? And then notice, you see how this 1 kind of works like this now. So 1010. Don't want to confuse you guys too much, but so yeah. So this is how binary kind of work. Now I want to give you guys a demonstration of this. Okay. So this is that, right? This is what I was talking about. So your computer actually, electricity goes through, and what happened is, if electricity flows through, let's say here, then I know I'm representing number 2, right? So if I put 1, it's 1 lights up. And if I want to represent 2 lights up, right? Because I don't need a 1. If I want to represent 3, they both light up. Now they add up to 3. Aha. And if I want to make it 4, remember, if these are all full 1s, I want to add a 1. These become 0, which means they become off, and this becomes a 1. 4. Right? 5. 4 plus 1 is 5. 4 plus 2 is 6. And if it's on, it just means it's a number 1. Okay? And notice they're all full now, right? 7. So I want to plus 1, make it 8. That means all these shuts off, and we get this light up. And notice there's a pattern. You see this, they're 2 times bigger than the previous number. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it doubles, because for every new position, digit, or like ones, maybe, well, I can't really say tens place, but for every extra number place that you get, you get to represent 2 times more than before, right? That's what it really means. And so if we go back to here, now let's say I want to represent the number 17, right? 17. You could just keep counting and do all that, but if you remember this pattern where it's 1, 2, 4, 8, 16, if I want to represent 17, what I have to do is put a 1 here, because I know this is going to be 16, because 1, 2, 4, 8, 16. So the fifth number, 1, 2, 3, 4, 5, the fifth number, 16. And then all I have to do is put a 1 at this place, and I get 17. Right? Same concept. If I want to do, let's say, 31. I want to represent 31. I can't represent 32 because that's too big, right? But what I could do is, I know if this is just 32